Okay, now we are going to see how to find a horizontal asymptote. Okay, so if a vertical asymptote, we are using case 3. When x approaches to a, you get positive or negative infinity. So for horizontal asymptote, we are going to use case 5. Okay, so what is case 5? Yang mana divide by highest power of denominator. Okay, so the same thing work here. You have to find limit x approaches to positive infinity, and also you have to show limit x approaches to negative infinity. Both must be shown. Okay, so now we have example 14. Let's take a look at example 14 here. So we have fx over x minus 2. Fx is equals to x over x minus 2. So here we know that we have to apply case 5 here. So we have limit x approaches to positive infinity. Our fx is x over x minus 2. So how do we know that this is case 5? First, this is x approaches to positive infinity. If we substitute it here, so this is infinity over infinity. So we have to divide by the highest power of the denominator. So what is the highest power of the denominator? We have x here. So each term must be divided by x. X over x minus 2 over x. Okay, so just simplify. So you will have x approaches to positive infinity, 1 over 1 minus 2 over x. Okay, so now just apply case 4. Substitute infinity dekat dalam fx kita. Ini a constant, so still 1. So here 1 minus 2 over infinity will be 0. So here your answer is 1. Okay, so you know that your y equals to 1 is a horizontal asymptote, but it hasn't finished yet. You still have to show limit x approaches to negative infinity. Okay, so we have our x here, x minus 2 equals to limit x approaches to negative infinity. Just do the same, exactly the same thing. Minus 2 over x. So limit x approaches to negative infinity. Here we have 1 minus 2 over x. So we have 1 over 1 minus 0. We still get 1. Okay, now we can already conclude that your y is equals to 1 is a horizontal asymptote. Okay, horizontal asymptote. Okay, so you must show x approaches to positive infinity and also x approaches to negative infinity. Okay, so you know from case 5 you have two cases. Okay, which is first just divided by the highest power of the denominator, and the other one is the special case with square root x square. So that one you may get your answer positive or negative. Okay, you may get your horizontal asymptote positive or negative because we have square root x square. But for this one you just get one answer here. Okay, but you still have to show both of x approaches positive and negative infinity. Okay, so now this one you can do it by yourself. Okay, just give me a second here. Okay. Okay, so here is the answer. Is y is equals to 2. Okay, you can do it by yourself. Y is equals to 2. Alright, so now I'm gonna proceed to the next example, which is we are going to see both vertical and horizontal asymptotes. Okay, from the previous video and this video combined together. So example 15, we have determined the vertical and horizontal asymptote of fx equals to 2x over square root x square plus 4. So this question a bit different for vertical asymptote. Okay, so first we want to find vertical asymptote first. Vertical asymptote. So from the previous video, we know that to find vertical asymptote, we have to use case 3. Okay, where you get a over 0 equals to positive or negative infinity. Okay, so first we have to look at our denominator. We have to know first what is the vertical asymptote, then we can do the limit. So from this question, we have the denominator is square root x square plus 4. Okay, so we take square root x square plus 4 is not equals to 0. And then we have x square plus 4 is not equals to 0. So here, as you can see from here, we have x square is not equals to negative 4. Okay. And then we have x is not equals to square root plus minus square root negative 4. Is this defined? Can we do this square root? Can negative be inside? Can a square root be a negative number? Okay. Nope. So that means what we can conclude here, since x is undefined, we can conclude that fx has no vertical asymptote. Has no vertical asymptote. Okay, so tak perlulah buat limit from the left, limit from the right. So we just consider that the denominator here we have undefined for x, so fx has no vertical asymptote. So let's proceed into the horizontal asymptote. Okay, so now we have a function fx equals to 2x over square root x square plus 4. So you know that horizontal asymptote, we have to apply case 5. Okay, so by looking at our function fx here, we know that we have to do special case here because we have square root x square. So to find horizontal asymptote, you have to find x approaches to positive infinity and also x approaches to negative infinity. So we have limit x approaches to positive infinity, 2x over square root x square plus 4. And also we have to do limit x approaches to negative infinity, 2x over square root x square plus 4. Okay, so let's do this one first. So first we have to take out square root x square first. Okay, the factorize square root x square, exactly the same like case 5. Okay, so from the previous video you can see how to do this one. So we have to factorize square root x square. So here should be 1 plus 4 over x square. So this one, since we have x approaches to positive infinity, this one should be, ya betul, positive x. Okay, so remember here we have modulus, sinilah saya tulis modulus x, sorry, square root x lah, square root x square is equals to positive x, negative x. This one is if x approaches to positive infinity, this one if x approaches to negative infinity. Okay, so now we know that your square root x square is positive x. So here is positive x. So now we can just divide everything by the highest power of the denominator, which is x dekat sini. Okay, contoh kalau ada constant dekat sini 9x, you can just abaikan the constant. Okay, kalau nak divide sekali, everything you have to divide by the constant, but just focus at the highest power of the denominator je. Okay, positive infinity, so we have to divide everything by x, x over x. Again, yang dalam jangan usik, 1 plus 4 over x square. So now this one will be 2, this one will be 1. So just substitute the value here. We will have 2 over square root 1 plus 0, and then here we will get 2. Okay, so you already know that y is equals to 2 is your horizontal asymptote. Okay, but you have another one here. We have to do one more here. So do exactly the same. Factorize our square root x square first. So factorize our square root x square. Dia tak bantu saya pula. Okay, square root x square. Benda yang sama, kita ulang je. So 1 plus 4 over x square. But here is the difference from this one. Here we have square root x square. Since x approaches to negative infinity, this one will be negative x. Okay, so we have limit x approaches to negative infinity, 2x over negative x, 1 plus 4 over x square. Okay, so divide by the highest power of the denominator, which is x. Okay, contoh macam ni yang saya cakap. This one you have negative, you can divide by negative x. Okay, this one you have to divide by negative x. Or if you would want to divide by x sahaja pun boleh juga, no problem. Okay, So here if you want to divide by x only, so here should be over x only lah. So 1 plus 4 over x square. Okay, simplify the answer. This one x. So we have 2 up here, and this one here we have negative square root 1 plus 0, which is you get the answer negative 2. Okay, don't forget to write your conclusion, since now we have y is equals to 2 and y is equals to negative 2. So the conclusion is y is equals to 2 and y is equals to negative 2 are horizontal asymptote. Horizontal asymptotes. Okay. That's it. How to find a vertical and horizontal asymptote. Okay. Okay, let's try last question here. Example 16. Okay, determine the vertical and horizontal asymptote of fx equals to 8 over x square minus 4. So first, vertical asymptote first. We have to look at our denominator. We have x square minus 4. So x square minus 4 is not equals to 0. So we have x plus 2. X minus 2 is not equals to 0, which is we will have x is not equals to negative 2, and also x is not equals to 2. Okay, plus minus 2. So as I said in the previous video, you have to find both. You have to show both for x equals to 2 and x equals to negative 2. Okay, so first when x equals to 2, okay, we do number line here. 2 from the right, 2 from the left, 2.1, 1.9. Okay, so limit x approaches 2 from the right. The function here is 8 over x square minus 4. Okay, so we have 8 over x square minus 4. We can write as x plus 2, x minus 2. 8. Okay, so here 2 plus 2 we get 4. Here 2 minus 2 we get 0. So 0 what? 0 from the right or 0 from the left? So here we have 2 positive, 2 from the right. We take the value of 2.1 minus 2, so we get positive value. That means this is 0 from the right. Okay, 8 over 0 positive. So we will have, so here we have 8 over 0 from the right. The answer here is positive infinity. Okay, so next we have limit x approaches to 2 from the left. So again do the same. X plus 2, x minus 2. So here we have 8. Here we still have 4. 2 from the left, which means we are going to get 1.9. 1.9 minus 2, you get negative value. So here is 0 negative. Okay, so we have 8 over 0 from the left. Here we get negative infinity. Okay, so you already know that x equals to 2 is your vertical asymptote. Okay, question. If let's say you have square root 0 positive, square root 0 negative. Here you have 8 over square root 0 negative. Okay, 8 over square root 0 from the left. 0, square root 0 from the left. Square root negative. That is undefined. Okay, so the answer here should be undefined. Okay, your answer should be undefined. If your answer is undefined, but you still have positive infinity for one of your x approaches to A from the right or from the left, your x is still considered as a vertical asymptote. Okay? Okay, kalau tak faham, tak apa, saya akan tunjukkan lagi contoh for that question. Now let's proceed to the next one. When x equals to negative 2, here we have the other one, x equals to negative 2. Okay, so let's quickly do this. We have negative 2. Negative 2 from the right, negative 2 from the left. Here is negative 1.9. Here is negative 2.1. Jangan tersalah to negative. So here we have limit x approaches to negative 2 from the right with a function 8 over x plus 2, x minus 2. So we have 8 over negative 2 plus 2. Negative 2 plus 2 from the right. So here is 0 positive. Okay, negative 1.9 plus 2. So here is 0 positive. And here is a negative 4. So a positive, positive here negative, you get 8 over 0 negative. That means you have negative infinity. And last one, we have limit x approaches to negative 2 from the left, x plus 2, x minus 2 equals to 8. So here, negative 2 from the left, we have negative 2.1 here, which is a negative value. So we have 0, negative. Here we have negative 4. So this one should be 0 from the right. So we have positive infinity. So now we can conclude our answer x equals to 2 and x equals to negative 2 are vertical asymptotes. Okay? Alright. So last one, we want to find horizontal asymptote. So again, apply case 5 to find horizontal asymptote. So what is case 5? We just substitute limit x approaches to positive infinity, 8 over x square minus 4, which is we have to divide by the highest power of the denominator, which is here is x square. Okay, so 8 over x square over x square over x square minus 4 over x square. Okay, simplifikanlah sendiri. And that should be 0 over 1 minus 0, which is the answer is 0. Okay, must show the other one also. Limit x approaches to negative infinity, 8 over x square minus 4. Again, do the same thing. Walaupun kita tahu jawapan dia sama. So we have x square over x square minus 4 over x square. So 0 over 1 minus 0 is equals to 0. Right, so we conclude that y equals to 0 is a horizontal asymptote. So that is your final answer. Okay, so now we know how to find vertical asymptotes and horizontal asymptote. Vertical asymptote by using case 3, horizontal asymptote by using case 5.